Today we're looking at, from a graph, forming an equation for a sine or a cosine function. Before we can do that, we need to learn some keywords and how to do some calculations. The keywords are the period, the amplitude, and the range. And also down the bottom you can see the screen on the left-hand side, letter C, which is a measure of a displacement, which we'll talk about later. Now, the period of a function is the length of a repeating pattern. So when you look at a graph, this is a sine graph, so happens, and what we have here is the length of a repeating pattern. And we can see it's a repeating pattern because we can see that it goes on to cover the next section. There are different ways of looking at repeating patterns. There's another version of a repeating pattern, and this one goes on to repeat off to the right in much the same way. Now, we have to work out the length of a repeating pattern. So it's better to use the black version because it starts at 0 and it ends at pi. Starts at 0 and it ends at pi. So therefore the length of the repeating pattern is pi minus 0. The next thing we're looking at is the range. Now, the range of a function is the function's lowest y value to its highest y value. So we look at the picture here and we can see that the lowest y value is +2 and the highest y value is 8. So therefore the range is the closed interval from 2 to 8. The amplitude, you need an imaginary middle line. You can see that this middle line splits the function in half. And now what we do is we mark from that middle line to a maximum, or indeed we can also mark from that middle line to a minimum. But the amplitude is the length of this line. And so the length of this line, we can just do it from the graph, is 1 unit, 2 units, 3 units. So we've got the length is equal to 3 units. You can also see that 2 amplitudes is equal to the length of the range in this particular case. So the length of this range is going to be 8 minus 2, which is 6. You divide that answer by 2 and you'll get 3. C, which is this part of the equation, is the displacement from the x-axis of the midline curve. So here I've marked in this displacement, and you can see the distance, displacement from the x-axis is +5 units. So therefore C is equal to 5. Now on this second slide, we're going to work through this again very, very quickly, just to, without any explanations as such, just to show you how quickly you need to be doing this in the exam. The first thing is we're looking at what the range of the function is. So the range is from the lowest to the highest point. Lowest point is 2, highest point is 8. Therefore the range is the closed interval 2 to 8. The amplitude, look at an imaginary middle line and then look at the length from that middle line to the top of the curve, say. And we know that that length from the graph is 1, 2, 3. So amplitude is equal to 3. The C is the displacement of this middle line from the origin. And this displacement is that distance there, and that distance or displacement is a +5. The period is a length of a repeating pattern. Using that one is very hard to measure the beginning and measure the end. So we choose this one to make it easier. So we can see here that the beginning of this starts at 0 and the end of this period starts at pi. And just to remind you, ends at pi. This is where it repeats over here. But the end of this pattern is pi. So therefore we now know that the period length is pi 0 to pi, or 0 to 180. Now, we said in the previous slide that we need a method for calculating the value of m. We've calculated the value of a, we've calculated the value of c. Now we need a method for calculating the value of m. We use this formula. You have to learn this formula. We've just calculated the value of p. The value of p is equal to 180. We're going to sub it into this formula. So m times p is the formula we're substituting into. It's 360. And we know that p is equal to 180. So therefore we divide both sides by 180 and we get m is equal to 2. So now we need to decide which graph it is. Now I'm telling you it's a sine graph. Now the way you work that out is you go to the imaginary middle line and you see where it cuts the y-axis. And if it's coming out of that imaginary line and going up, you know it's a sine curve. I'm afraid you have to learn that for now. I will give you some reasoning as to why that is the case, but for now you have to learn it. Do we know what a is? Yes, we do. We know that a is equal to 3, we know that m is equal to 2, and we know that c is equal to 5, and therefore we're now in a position to substitute in and derive the equation of our line. So now we're going to look at 4 different examples, and again just repeat the same thing over again. You can pause the video at this point and then maybe try and work out the answers yourself. If you can do that, and then the video confirms that you're right, then you completely understand the work. And that's the approach I would like you to adopt, rather than just looking at this video. Okay, you can pause the video now. Right, here's the answers to what you have just done, I hope. The range is the highest, lowest, starting at the lowest, going to the highest. So the lowest y value for this curve is -1. The highest y value is 1, so the range is equal to 1. The amplitude is going from the middle line to the highest point, or from the middle line to the lowest point, doesn't matter which one you choose, but clearly the length of this line is equal to 1. So the amplitude is equal to 1. C is the displacement of the middle line from the x-axis, but the middle line is the x-axis, so there is no displacement, so the value of c is equal to 0. We now need to work out the period. So we start on the middle line, on the y-axis, and we draw a curve until it begins to repeat. And it starts to repeat here. And so we now know that the length of our period, which is what we're calculating, it's what we're always calculating, the length of our period is equal to pi. Now I actually prefer to work in degrees, but that's just me. So the length of our period is 180 degrees. I now need to work out the equation of my graph. And before I can work out the equation of my graph, I need to work out the value of m. So from memory, I quote the formula m times period is equal to 360 degrees. I substitute my value for period in, which is 180. I now divide both sides by 180 and get m equals to 2. I need to decide whether this is a sine curve or a cosine curve. So I go back to where I drew my period, and I started drawing my period here, and it started travelling up immediately. And because it started travelling up in that first quadrant immediately, I now know it's a sine curve. And again, it's something you have to learn. So I am now going to write down here the general formula for the sine curve, which is a sine mx plus c. And a is equal to 1, and m is equal to 2, and c is equal to 0. So I can complete my equation, and it's y is equal to sine 2x. Okay, I'm going on now to the next example. Now this example is slightly harder, when it comes to finding the period. So I'd like you to pause the video at this moment in time. I'd like you to calculate the range yourself, the amplitude yourself, and the value of C yourselves. And then when you've done that, you can restart the video, and then I will start working on the period. Okay, you've had enough time now to work out the range. Well, you should have, because you can pause the video for as long as you like. So the range, what's the lowest y value? Well, the lowest y value for this curve is -2. The highest y value for this curve is a +2. So we now know the range is running from -2 to +2. So we have a closed interval of -2 to +2. The altitude is from the middle line to the topmost point, which is a distance of 2. So we've got the altitude as 2. The middle line is on the x-axis, and because the middle line is on the x-axis, we know the displacement is 0. I hope you got that right. Now the period for this one is slightly harder. So if you wish to pause the video and see if you can work it out for yourselves, please do so. You can pause it now. Otherwise, we'll just go on with the graph. So I go to where the graph is touching the y-axis. So this time it is above the middle line, and it's coming down. Now, because it's above the middle line and coming down, I actually know it's not a sine, so therefore it must be a cosine curve. So it's coming down, and now I want to work out what the period is. So I come round to here, and I'm coming up to the end of the first period, and here is the end of the first period. And unfortunately, I'm looking at the answer down here, and it's very hard to read it. So inconclusive. So what I'm going to do now is I'm going to go on and do a second period. So this is period number 2. So I'm drawing period number 2, and keep going until I get to the top of the second period, and I look down to read off what the answer is, and I don't know it. It's inconclusive. So now I'm going to have to draw a third period. So I draw the third period, and I come on round, and I come to the top, and fortunately there is a measurement, and that measurement is 2 pi, or 360 degrees, whichever you choose to use. I started at 0 and I finished at 360, but this is not a period. This was 3 periods is equal to 360 degrees. So therefore, dividing both sides by 2, 1 period is equal to 120 degrees. I could now use the equation m times period is equal to 360 degrees. And if you write that down now, you might spot that you've actually got that equation here. And by inspection, that m is equal to 3. But if you did not spot that, then you'll probably do this. Substitute p for 120, then divide both sides by 120. So 360 divided by 120 is 3. You now are in a position to write down the general equation. Now, what I said earlier on, and I'll go back and explain it again now, is it's a cos function. Now, if we go back to the middle line is here, and joining the y-axis is here, and if it was a sine curve, it would be coming out. But it isn't starting at the bottom going up, it's starting at the top coming down, which means it's not a sine curve, so therefore it must be a cosine curve. So we've got y is equal to a is equal to 2, so cos, m is equal to 3, x, and c we'd already calculated is equal to 0. So the equation of this curve is 2 cos 3x. We go on to example number 3. You can pause and make notes, take photographs, copy it out. Now, so we're on to this graph here, and again I want you to pause the video and work through the whole lot yourself. The lowest y value is 1. The highest y value for this graph is 7. So the range is the closed interval 1 to 7. The amplitude is, well, the amplitude is 3. The imaginary middle line is here, and 4 up to 7 is a distance of 3. But you could have also done it from the range numbers. The top range minus the bottom range divided by 2. 7 minus 1 is 6. 6 divided by 2 is 3. I should have mentioned that earlier on. The displacement number. Well, I've just drawn a dotted version of the imaginary middle line, and so therefore the displacement from the x-axis up to this midline is 4. So we know that the displacement is a plus 4. We now need to calculate the period. To calculate the period, we start at the point on the y-axis and we draw on the curve or run our finger along the curve until we get to the end of the first part of the smallest repeating pattern, which is here. Do I have a corresponding value underneath? Yes, I do. It's pi, or 180 degrees. So what I've got here is it's going to be the length of this repeating pattern is 180 minus 0, so it's going to be 180 degrees. Now, to work out the equation, we need to use the formula MP is equal to 360 degrees. As I say, a formula that you have to learn. We know the period is 180, so M times 180 is equal to 360 degrees. We need to divide both sides by 180 degrees. So 360 divided by 180 is equal to 2. So we've got M is equal to 2. We've already identified the fact that the middle line is here and that the curve is not starting from the point where those two lines meet. It's starting at the top and coming down. So we know it's a cos function. So the general form is a cos mx plus c. So we know that y is equal to the amplitude, which is 3, and we've got cos m is equal to 2 on x, and c is equal to 4, so we've got plus 4. I hope you got it right. Now we're going to go on to the final example. Once again, I'm going to ask you to pause the video at this point. What we have here is the range. So what's the lowest y value? Well, the lowest y value is equal to minus 7. So we've got the closed interval starting at minus 7, and it goes up as far as minus 3. So there's the range from minus 7 to minus 3, the lowest y value to the highest y value. We are then looking for the amplitude. So we look at the imaginary middle line. So there's our imaginary middle line. And the amplitude is the distance from that imaginary middle line to the maximum point, or from that imaginary middle line to the minimum point. So clearly from the graph, that's 2. What's the displacement? Well, the displacement is the distance from the x-axis, displacement from the x-axis down to the middle line. And it's quite obvious that that displacement is in a negative direction, so therefore it's going to be a minus number, and it's a displacement of 5, so it's minus 5. We're now going to work out the period of our function. So we go back to the y-axis, and it just happens to be starting on and going up. Now, because it's starting on the dotted imaginary middle line and going up, we now know that the function is going to be a sine function. So we draw the period, we keep drawing till we get to the end of the period until it starts to repeat, which is here. Now, unfortunately, if we look up above, there's no definite value for that point, so we have to repeat that period again. So repeating that period again, and we come back to a point and we track that point up, and there's no definite value it matches. So then we draw the period again, and when we draw the period for the third time, period ends here. When we track it up, there is a definite value of 2 pi or 360 degrees. Now, we haven't worked out what one period is, we've worked out what 3 periods are. So 3 periods is equal to 360 degrees. So dividing both sides by 3, we've got 1 period is 120 degrees. We can now use the formula MP equals 360. And at this point, you should have spotted that M is clearly equal to 3. If unfortunately you don't spot that, then you're going to be doing extra work, putting in 120, then dividing both sides by 120 and getting 3 2 lines later. We've already identified that this is a sine function, so a sine mx plus c is the general form. So we know the value of a is 2, we know the value of m is equal to 3, and we know the value of c, the displacement, is -5. So that's the end of that problem. I hope you got it right. There's a couple of tasks you can try from the textbook. Here's the first one, and here is the second one, which I will go over in class.